We now have our first box, we have the basic components to make a functional map, and we've done a few quick test compiles to get in game and run around. But what exactly is going on when we compile? Compiling your map is converting it from the text-based VMF file to a BSP file that can be read by the engine. It is using your computer to process certain aspects of the map to save the end user from having to. This includes checking it for leaks, visibility calculations, and static lighting. The three stages to a compile are VBSP, VVIS, and VRAD. This is the basic conversion of your map into the BSP file. This is where it checks to make sure your map doesn't have any leaks or any other major errors. This step also fills the inside of your map with things called viz leaves. Viz leaves are a series of boxes that take up the empty or negative space of your map. These boxes are for use in the next step of the compile process. This step is usually very fast and generally you won't ever have to change this option. This step of the compile is looking at your viz leaves and calculating visibility based off of which of these boxes can see each other and stores that data in the map. In-game, if a player is standing in one of these boxes, anything inside of it and anything inside any other viz leaves that can be seen by that box will also be rendered. Basically, if you can draw a straight line from one viz leaf to the other, everything in that other box will render, even if it's not actually visible to the player. There are a few tricks you can do to manipulate these, but this is a pretty complex topic that we'll get into much more detail in a future episode. Setting this option to fast is causing it to do just a quick pass and does not test for visibility. This will speed up your compile, but everything in your map will render for the player, leading to horrible performance in the end. It is important to never release a map with a fast compile. It is, however, really useful for a quick runaround test when your map is getting more complex and takes longer to compile. This stage of the compile is what calculates the static lighting in your map. It is bouncing light around your map based off of a rather fancy radiosity algorithm and creates realistic lighting that reflects based on the material on your map. The most basic concept of this is that lighter colors reflect more light. This stage also calculates the lighting for all of your props to give them the right look in their current lighting settings. Being a pretty old engine at this point, it's not a perfect system, but it gets the job done and can create some pretty cool effects. This is usually the slowest of the three compiling steps due to the extensive calculations it has to perform. Once your map reaches a certain complexity, Hammer will appear to freeze up during its compile. Usually this isn't a bad sign though, so just wait it out. The HDR checkbox is for high dynamic range lighting, which is the bloom effects you may see in bright lighting situations. This is something you can start thinking about in the detailing stage of your map though, so don't worry about it for now. Setting this stage to fast causes some very basic lighting with few bounces, but can drastically speed up your compile time for a quick in-game runaround. But again, it's not a good idea to release a map with a fast compile here either. Below these stages, you can choose to run a map after your compile or not. Some people have issues with Hammer launching TF2, so they can choose to manually load it up and select their map with this option. The compiler automatically places your map file in the proper folder of TF2. Below that is the additional game parameters box. This box is generally for more advanced options, but you can see that I have a few in here myself. These options launch TF2 in a windowed mode, get rid of the window border, set the resolution to 1920 by 1080, and finally get rid of the opening splash screen video to save a few seconds on my load. If you wish to use these options, feel free to use these exact settings, substituting your own native resolution. The expert button is a dark and scary place for advanced users, so just leave it alone, you noob. Now, we can always hope to never make any mistakes while mapping, but errors are inevitable. There are a wide range of issues that can arise while creating a map, and the more complex it is, the higher chance there is of an error occurring. Some errors are minor and don't even cause issues with your map. Some can be so major that your compile stops itself completely. The telltale sign of a major compile breaking error is when it's completed and your map loads up and doesn't have any of the changes you recently made. When you start your compile, the compile process window will pop up and a ton of information will fly by. It tends to freeze up with anything but the most basic compile, but once it's complete and your map loads, you can scan over this log for any potential issues. You'll notice where it says executing, each stage previously listed as ran. Issues can arise during any of these stages, and learning to identify the different error notices is key to solving any problem. The most common error is a leak, which, as I described earlier in the series, is when the interior map is in contact with the void outside of it. This is sorted out by grabbing an entity and seeing if it's exposed by any means to the void. When this occurs, the compiler is unable to tell the difference between the inside of your map and the outside, and it causes errors in both your visibility and lighting. A common sign of a map having a leak is extremely dark lighting in places caused by the VRAD stage not bouncing light properly, and very poor frame rate caused by most, if not all, of the map rendering for the player at once. A leak looks like this in your compile log and will appear in the middle of your VBSP stage. It will tell you what entity leaked and where the entity is on your map. To go to those coordinates, click on View, Go to Coordinates, and type in the numbers listed in your log. This takes us directly to the entity that the compiler identified as leaking into the void, but it still isn't always clear exactly how this entity is leaking. Another tool we have for that are point files. A point file is generated by your compile that points out exactly where and how your map is leaking. It is only generated when your map leaks, otherwise it won't exist. To load it up, click on Map, Load Point File. If a window pops up asking to load the default point file, it means it was generated. If it asks you to select a file, that means it was not and your error may lie elsewhere. Loading up our point file draws a red line from our entity and out of our map into the void. To fix our issue, we simply need to plug our hole in the map to stop our leak. Sometimes, especially with big changes to a complex map, multiple leaks can occur. However, the point file will only be generated for one leak at a time. A trick to speed up the process of finding them is to bring up your compile window, set VSP to normal, and VIS and RAD to no. Then check Don't Run the Game after compiling and hit OK. This causes the compiler to only run the BSP stage of your compile and will very quickly and efficiently generate a new point file for you to check. Now let's say you have an error that isn't a leak. Let's say your map is doing something strange and you're not sure what to look for in your compile log. A handy tool for that is the Interlopers Error Checker. A link to this tool will be in the description below. What this tool does is scan your entire compile log and point out any problem areas. Usually it will give you a brief explanation of what the error is, how dire it is to your compile, and if you're lucky, what to do to solve it. In the description, I also included a link to the Valve Developer Wiki's list of common compile errors. This is a very handy resource if the error checker doesn't seem to be solving your problem. And if all else fails, you can always head over to tf2maps.net with a brief description of your problem and a copy of your compile log and let the grizzled hammered veterans give it a look over. Unless you're doing something very advanced or complex, there's a good chance someone over there has had your problem at some point and can offer you a solution. And with that, we will conclude Chapter 1 of How to Make TF2 Maps, brought to you by tf2maps.net and essentials.tf. If you have enjoyed the series and wish to keep up with it, consider subscribing to this channel. I look forward to hearing about all the cool stuff you guys create, so let me know about some of it in the comments section below.